Hey everybody, in this video, learning target 22, I'll be going over how to interpret integrals in terms of the areas and then also using Riemann sums to calculate a definite integral. So in part A, we're given a graph of f of x and we're supposed to calculate the integral from 0 to 4 of this f of x function by interpreting it in terms of area. And looking at our graph, it's all straight lines, which means shapes, and shapes are pretty easy to calculate the integral of. If I had some curve like this, I couldn't just tell you what the area of this is and the area of this is based on just calculating it like geometrically. But looking at this, I have straight lines, so I can calculate the area of that. So let's go ahead and do it. We're going to have some different shapes because I can't take the area of this all at once. So that'll be a shape, and then this will be a shape. I see a square here, and then finally a triangle. Sometimes you can calculate the area of a trapezoid or something like that, but I think the easiest way to do it is just in terms of squares, rectangles, and triangles. That'll probably be the easiest thing to do. So an integral, what that really means, it's the area under the curve. But if we have negative, if we have below the curve, then, or below the axis, this x-axis, then this shape looks like to be negative. Anyways, let's just go ahead and calculate the actual area of each individual shape. So this one, I will have, it's a triangle, so 1/2 base. The base is also 1/2 times height. The height is going to be 1. It's just equal to a fourth. And then this shape here, 1/2. The base is also going to be 1/2. And the height is going to be 1. So this is equal to 1/4 as well. But as I mentioned earlier, this first triangle right here, it's below the x-axis, which means it's negative. And I have a negative 1/4 here and a positive 1/4 here. So I'm pretty much going to cancel these out. And this makes sense because I have this triangle here under the curve and this triangle here over the curve, and they're exactly identical. Just, or sorry, I said over the curve. I mean below and above the x-axis. This is below the x-axis. This is above the x-axis. They're the same area, so they'll pretty much cancel out when it comes to the integral. So that makes this a little bit easier. Let's do the square now. Easy enough. It's 1 by 1, which equals 1. And then finally, this triangle of 1/2 base times height, where the base is going to be 2, from 2 to 4. The height is 1 again. This just equals 1. So we're including this shape and this triangle as well. So that means the area and the integral is equal to 2. In part B, we're given a graph of a function. We're going to use left Riemann sum to calculate, or the left-hand approximation to calculate this integral. And the reason we can't use like the area method we just did is what I was talking about earlier. It's not a easy curve to geometrically define because we have these smooth curve. So we need to use a Riemann sum, left-handed. So left-handed means I'm going to be drawing my rectangles starting from the left. And we're going from 0 to 3, and it's an elf sub 3. And it tells us here 3 rectangles. So starting at 0, left-handed means I'm going to start at this point, go across, and that'll be 1. Now at the point 1, we go to the left side right here. That's our next one. And then finally, for our third rectangle, at x equals 2, start here. Same deal. Now we can calculate the area of these shapes, and it's easy to do because they're rectangles. So the first one, that's just 1 times 1, which equals 1. And I'll This is shape 1, shape 2, and shape 3. Shape 2, we have it's 3 high, base is 1 again, so 3. And then the third shape, third rectangle, is 4 high, base is 1. So summing those all up, we have that our L3 is equal to 8. Not too bad. Just a quick little summary. We have, in this first case, we want to calculate the integral using areas. So we're going to split this up into shapes. We can easily take the area of. Below the x-axis, that's technically negative area. So in this case, since these two shapes are identical, but one's above and one's below the x-axis, they cancel out. Then we just have a square and we have a triangle, which are easy enough to calculate the areas of. We add those up, and then we have our estimate of the integral. In part B, we need to use a Riemann sum, specifically a left-handed approximation in this case. And it says we need 3 rectangles, which is indicated by L sub 3, 3 rectangles, using the left endpoints. So going along this curve, at x equals 0, we have our rectangle. At x equals 1, we have a rectangle. And at x equals 2. And then we calculate the areas of those rectangles, add them up, and we get our approximation.